So today is Tuesday, November 27th, and we are doing Eureka Math, Module 2, Lesson 25. Okay, and as you can see by your learning goal, today you're still using what you know about place value and math facts, but today we're using it to help us estimate the quotient. Let's talk really quickly about what that means. What does it mean to estimate? What does it mean to estimate? Taryn?
Something close to that number,
Oh.
easy way to multiply or divide.
It means that we're finding something close to the real answer. Are we finding the exact real answer? No, and we're doing it using numbers that are easy to think about in our heads, that we don't really need to write it down and do the standard algorithm to do it, okay? And what about if we're estimating, we're finding something close to the quotient. What's the quotient? What are we estimating? What's a quotient? What's a quotient? Geffen, give it a try.
Like not the equals, but
The answer?
Yeah.
To what kind of problem?
to multiply,
Not to multiplying.
to divide.
Good. The quotient is the answer to a division problem. So today we're going to use what we know about place value and math facts to help us figure out an answer that's pretty close to the real answer. Very good. The directions tell us to estimate the quotient, and here's your math problem that you're going to copy into your notebook. 39.1 divided by 17. Whenever we have a division problem we need to estimate, what do we estimate first? The whole or the divisor? The divisor. Here's a good way for you to remember that if you always forget. Divisor starts with D and whole starts with W. Do you agree? Which letter comes first in the alphabet, D or W? D. So you got to estimate the divisor first. Remember, we have to estimate the divisor because it helps us understand what math facts we're thinking about when we estimate the whole. Does that make sense? When we round the whole. So, the divisor, is that a multiple of 10, 17? No. But it's pretty close to 1. What is it close to? 20. Okay, so we're going to say that that's pretty close to 20. And now that we know our divisor, we've rounded it to 20. Everyone show me on your fingers what math facts, what fact family are we going to think about then? We're going to think about our 2's. Very good. So 39.1 is pretty close to what number that's compatible with your 2's? Everyone? 40. I agree that 39.1 is pretty close to 40. Okay, what's 40 divided by 2? I mean by 20? 2. So our estimated quotient then is 2. Does that mean that 39.1 divided by 17 is equal to 2? It just means our final answer should be pretty close to 2. Very good. Okay, here's another problem that's kind of related. 33.91 divided by 17. So if you know that in your first answer here, 39.1 divided by 17 is pretty close to 2, how does the second number compare, the second equation? What's the same? What's the same between these two equations? Rishit? They both have the same divisor. We're dividing them by the same thing, 17. Oh, I also noticed they all have 391 in the whole. Do you guys see that? Okay, so we can see that they have a 3, a 9, and then a 1. A 3, a 9, and a 1. But what's different? One of them's 39.1 and one's 3.91. So which one's bigger? Everyone? 39.1 is bigger. How many times bigger is it than 3.91? 10 times bigger. So in order to get from 39.1 to 3.91, I divided by 10, right? What does that mean for my answer? If I'm starting out with 39, which is close to 40, and I'm going to divide it by something that's close to 20, I'm going to end up with 2, right? What about this time? Let's estimate. 3.91 is pretty close to what number? 4, right? So this was 4 tens, and this is 4 ones. Do you agree? Yeah. So how is that going to affect my quotient? Is my quotient going to be bigger or smaller than 2? Smaller. How many times smaller? So in order to figure out what this quotient is going to be, I have to divide 2 by 10, which is 2 tenths. So based on the first equation, I can see that my second equation, the answer is going to be close to 2 tenths. You'll notice I use the wavy equal signs because it's not the exact answer. Do you agree? Very good. Wait a second. We rounded our divisor because 73 is pretty close to 70, and then we used our 7 fact families to know that 63 is part of the 7 fact family. But again, I'm running into the same problem I saw in my problem of the day. My whole, 63, is smaller than my divisor, 70. What does that mean I need to do? I need to rename these units. Instead of calling it 63 ones, I can also name it as 630 what? Tenths. I hope you're writing this down. And now, is it bigger than 70? It is. What is 630 divided by 70? 9. But what is my units? Tenths. So therefore, in standard form, 63.6 divided by 73 is pretty close to 0.9. So again, this example shows you that sometimes you might find, my whole is smaller than my divisor, right? Then all you need to do, rename the units. It automatically makes your whole bigger, sort of, right? Does it change the value of your whole? It just changes the way you're looking at it, changes the units of it, okay? Let's use what we know. If we know that 63.6 divided by 73 is pretty close to 0.9, how would this answer be? What's the same between the two equations? What's the same, Taylor? We're both dividing by 63. What's different about the two equations? Lydia?
Even though the whole has the same digits in the same order, it's 10 times less.
Yeah, this one is 10 times smaller. So if we're starting with something that's 10 times smaller, are we going to end up, if we're dividing it, it's like if I gave Paulina $100 to split between people, but I only gave Karis $10. That's 10 times less. Who's going to end up with more when they split it? Paulina. How many times more? 10 times more, because she started with 10 times more. So what's the answer? What's a good estimate for this bottom equation then? It's going to be whatever is 10 times smaller than 0.9, right? So it'd be 10 times less. We have to, in order to find what's 10 times less, we have to divide by 10, which will be 0.09 or 9 hundredths. Very nice.